Hello, my name is Danny St. Louis, and I decided to do my presentation on HTTP and Internet Protocol. This is the overview. I'll be covering overview of HTTP, the core principles of it, the role of it, the function, and its placement in the OSI or TCP/IP suite. HTTP's main operations, history of HTTP and significant updates to maintain its relevance, current applications and network operations, and also how to improve it. Topic 1. Designed in the early 1990s, the Hypertext Transfer Protocol, HTTP, is the foundation of the World Wide Web and is used to upload web pages using hypertext links. It can also be used for fetching resources such as the Hypertext Markup Language, HTML, documents. HTTP is a client-server protocol, which means that requests are initiated by the recipient, usually the web browser. Topic 2. Core principles. The core principles define HTTP, statelessness, and client-server model. Statelessness means that each request from a client to a server is treated as an independent transaction that is unrelated to any previous request. Client-server model is in a typically HTTP request flow. The communication is always initiated by the client, as I mentioned, usually a web browser or application. The server hosts resources like web pages, APIs, and files and waits for incoming requests. Role. The role of HTTP is mainly to request and transfer data like HTML, pages, images, and videos. How it works is that it enables web browsers to request and receive web contents using methods like get, post, and put. Well, I think I'll get into that later too. But how it mostly operates is there's like 5 steps, I think. Step 1, it directs the browser to a URL. Step 2, browser looks up the IP. Step 3, browser sends HTTP request. Step 4, host sends back HTTP response. And step 5, the browser renders the response. Topic 5, placement in the OSI or TCP/IP suite. HTTP operates at the layer 7 or application layer in the OSI model and also the application layer in the TCP/IP model. Topic 6, main operations. HTTP's main operations is to transmit data over the internet, and it has different methods to do so. Like I mentioned before, get, post, put are some of them, but there's also delete, head, and patch. Get retrieves data from the server. Post sends data to the server to create a new source. Put sends updates an existing resource on the server. Delete removes the resource from the server. Head retrieves only the headers of response without the actual data, and patch partially updates an existing source. Topic 7. History of HTTP and significant updates. As I've mentioned already, HTTP was created in around the 1990s. Specifically 1989 to 1991 by Tim Berners-Lee. At first, HTTP wasn't really called that. It was actually called, it was called the mesh before it was called the World Wide Web. And there has been currently 6 different versions of it. First version was 0.9. This one was really simple. There was no headers, no status codes, no cookies, just a single command, and that was get. Now, HTTP version 1.0 was starting to get serious. With HTTP 1.0, things got real. Headers were introduced, along with status codes, and more support for HTTP verbs like post and head. HTTP version 1.1 was basically like the internet's workhorse. It stayed relevant for 20 years, but eventually started to buckle under the weight of modern web demands. The biggest issue was head-of-line blocking. Only one request could be in flight at a time per connection, and browsers had to open multiple connections to work around it. It was messy and inefficient. HTTP version 2 was a big upgrade. It was really like a breath of fresh air. A binary protocol instead of text, multiplexing, header compression, server push. HTTP version 3 was based more on UDP instead of TCP, and it solved many legacy issues. No more head-of-line blocking, faster connection setup, and built-in encryption. It was fast, secure, and better suited for mobile networks, but it's also complex, difficult to debug, and not universally supported. I would say that we still lack, although HTTP version 3 is, okay, I think we still lack fine-grained quality of service, native support for things like streaming UI updates, and developer-friendly diagnostics and debugging. Topic 8, current applications, web browsing and content delivery, API-based services, and network management and proxies. I don't really have too much on that. Topic 9, how to improve. Like I said before, I think we definitely need more developer-friendly diagnostics and debugging, and true app layer security primitives. Also, definitely fine-grained quality of service. These are my references. Any questions? And thank you.